Hi, this is the
Hi.
Data Science Barcelona podcast. We try to interview people who's doing interesting things in data science and with some connection to the city. Today we are interviewing Eduard. Um he is working at a top-notch company, let's say. Wallapop is the biggest marketplace right now in Spain, right?
Mhm.
Um, so yeah, hi, how are you? Um,
Good. Thank you for having me here, giving me the chance to I don't know, to talk a little bit about myself and about my point of view about data science, and hopefully it can be helpful for someone watching
sure,
this video.
sure. I'm sure many people want to see your perspective.
Mhm.
Um, so tell me a bit about your trajectory.
Mhm. So the way I became a data scientist, it all began when I started studying mathematics and physics at the University of Barcelona. And as many of my colleagues, it was because we liked the solving like problems and understanding how the world work. And I got really interested in, let's say, particle physics, quantum physics, and so on. I wanted to be to work in that field and to be in research, doing research. But at some point, I also learned about data science and what it meant to build mathematical models to solve real life problems. And I loved the idea also because I discovered programming at the same time, and I really like it. And that's where when I was faced between deciding going to academia for, let's say, quantum physics and quantum computation, actually, or choosing data science, that was the moment that I decided it was better for me, or I feel, or I like it better to do data science. Um, Actually, I also like quantum computation, and at some point it might come together because there's this idea of quantum machine learning, and hopefully at some point in the future I will be able to join both fields. But anyway, then after that, I started working before studying anything else because I wanted to like gain experience, and I was working in a consultancy company as BI consultant, business intelligence consultant. For those who don't know what is business intelligence, it's kind of data related. It's not really data science, or well, it all depends on your definition. But it's building or all the tools and strategies that business have to get value from data. And it basically means building ETLs, which is the processes from taking the data from one place and loading it to another place, and building dashboard and reporting tools around that for business and people in management to take decisions based on that. So I worked in that company for a couple of years, one in Barcelona, and then I got the chance to move to Abu Dhabi, UAE, and work with customers there. And I learned a lot. I learned a lot about management and technical project management and gathering requirements and programming also databases, all of that. And at the end, it was really helpful to build like the part that I was lacking of knowledge, the computer science part. And then I come back to Barcelona. I took a master in data science at the University of Barcelona, and that completed my let's say my basis, which at the end allowed me to get into data science and to work at Wallapop.
Okay, so yeah, could you tell us a bit more about your experience in business intelligence in your particular enterprise? Who did you talk to, or which places did you go?
Yes, so actually, I think that can be really frustrating for many people out there to really understand which is the data positions, which are the data positions in companies. And that was something I really didn't know at that point, and that at the beginning was confusing for me. So I learned a little bit about data science. I did a postgraduate course before finishing my bachelor. And I like it. I like it, machine learning, but I didn't know that business intelligence is not machine learning. And but also I learned that it was also useful and helpful to know about all this other stuff, because at the end, at my work at Wallapop, as data scientists, pure data scientists, if you will, if you want, in a company, there's a lot of time, you spend a lot of time doing business intelligence tools, things too, like building ETLs, bringing in the data, building the data set, building dashboards with the results of your models, or providing analysis to other colleagues. So that really helped the experience there. And yeah, so basically it was a couple of years of learning a lot of SQL, a lot of reporting tools, and building in several projects to at the end, the idea is the same. You have a challenge, a business challenge, and you want to get value from the data, and how you plan the project, and which tools you build to give value to this data. And another really important thing is how you explain this value to people that is not really data, well, that is not really good, or is not the skills are not really about data. So how you translate the results for common people.
Do you think data scientists should be more like business intelligence, or we should learn from them?
Well, at the end, it all depends on what you are looking for. So there is this Venn diagram, you know, the three circles that some people use to define what is a data scientist. And well, the most common definition, we might agree or disagree, but it's basically a data scientist is made of three components. It's the mathematics and statistics, the business, and computer science. And depending on which pillars you support, or which is your direction, you might be in some part of this diagram. Ideally, everyone would like to be in the middle, because it's where you have knowledge of everything.
The unicorn.
Yeah, the unicorn. But yeah, how I see it is that you try to move around until you find your sweet spot. And in that sense, business intelligence is probably between business and computer science. So I already had the background in mathematics, so that was helpful. I mean, I didn't know how to do SQL before joining before working there, and at the end, that's a must for working in data related things.
Mm-hmm. There's some criticism, though, on the definition of data scientists. There's like skeptical people that say it's not clearly defined, or
I totally agree.
Oh, you agree?
Yeah. I was saying that before. So when I joined as a business intelligence consultant, I really didn't know the meaning of business intelligence. Then you might find some other words like business analyst, data analyst, data engineer, machine learning engineer, data scientist. There are many definitions, and there are many words, and each of them might have a different definition depending on who you ask. But I think we can commonly agree that a data scientist is someone between machine learning and statistics. But yeah, also depends. I mean, it might depend on the role. I have some colleagues that are data scientists, but work more on not on machine learning, but other kind of statistical models. And at the end, the definition is quite broad, and it might change. It depends on who you ask, and we'll see in the future how it evolves. But it's basically data related with models and machine learning.
Solving a problem with data.
Exactly.
Yeah. So the next question would be about some occasion where you like nailed an interview, or something gave you an advantage. If you would like to share with us.
So actually, I've only worked in two companies. For this other Clitipix, the consultancy company, and Wallapop. And I think the second one is when I was better positioned to get the job. Mostly, and also not mostly, but partially because one of the colleagues of the master was the one who introduced myself. She was working at Wallapop, and she helped me get the interview, and that helped a lot in getting recommended. But on the other hand, what helped me, I think, being the position that I am right now, is building these three pillars and making sure that I could be as polyvalent or as possible, both in the statistics part, the mathematics part, the machine learning part, and the business side. So that's what I think. Building this strong basics across the platform, because at the end what I was thinking was for a job like that. If you want to be more in the academia, maybe you don't need the business side of the diary program, but for the position, I think that helped.
Okay, so we could say referrals are good.
Yeah,
and having a broad tool set also. Okay, that's nice. Yeah, let's go with the next one. Which lessons did you learn, or did you have some realization?
So I learned that it's hard to communicate about data and about what you know, or at least for me, it is hard. And it's one of the most important parts if you work in a company, is how you can communicate the results to the appropriate people. Because otherwise you might have like a 90% accuracy in your, or 99% accuracy in your machine learning model. But if you're not able to explain how this can help the business, or which benefits, or how they can take this decision from that, it might be useless. So learning how to communicate that, it's really important, and it's not easy. I don't think that I mastered that, but I think it's important.
You know, now that you mentioned this, a guy contacted on LinkedIn offering me knowledge on communication about data science, like English for data scientists.
Not bad.
And I actually took it because I think it's important.
Yeah, totally. It's communication in that. That's what I was saying. If you work if you like to work in the company business side, knowing how to communicate, it's important. In academia, it's also important, but as you mostly work with peers that have the same sort of knowledge, it's not that important to be able to bring the technical details to the ground and to explain them to business people.
Yes, but many times, many of the lessons learned in business also apply to academia, like not ignoring the business side, or the human component of the listener and all that stuff. I think.
Yeah. Well, at the end, academia and research might and will have applications to the business. So learning from the needs there, it's also useful. But yeah.
Sorry, interrupted you. Go on.
No, basically that. One of the things that I didn't thought of before joining or before starting working in that field was realizing how difficult it is to explain and to make people understand what a 98% accuracy in a model can do.
Okay. Yeah, it's important, definitely. So I agree. Did you think about an anecdote in your career?
Yeah, maybe. So working as a consultant, you asked me before. I was 1 year based in Barcelona in the offices, but then I was the second year working as a consultant, but within the client. So I was working as part of the team in the client, some of the top firms in Abu Dhabi, and there were many strange requirements. Like I cannot disclose all of them, but for instance, once we were asked to build a dashboard to be shown to the CEO, to the top level of the company. And we were asked to have like some horses racing against each other to represent the KPIs and the metrics, how were the metric advancing them. So that was strange when you see that people just seeks or wants to have something nice and without really caring about the value behind that. So we were just asked to like put horses and caps saying that's the winner and that's the loser. That was strange.
Yeah. I can see the point in it, but yeah, it's
But
a bit
when you
uncommon.
lose when you lose what's the main thing about the dashboard, and you focus on these weird, strange requirements, yeah. But yeah, well, consultants get many of those things. And yeah, that's it. The other thing maybe is that how surprisingly small it is, the data science world here in Barcelona. Maybe you've faced the same, but it gets to a point that you know many people in data science, and you do connections across. Like you go to a company and you realize, oh, that guy is the guy that worked with the other person there, and how small at the end it becomes.
Yeah, there's a strong community, pretty connected in Barcelona, I think. Okay, so what would you define that's your area of expertise? What do you do?
So I don't consider myself an expert yet, or
Yeah, of course.
maybe never, but because my experience in data science is a bit short. But in the past year and a half, which is the time I've been working at Wallapop, I've learned a lot about how to bring data science products, let's say, to real use cases, and how to integrate those products within the value or the platform. As you were saying, Wallapop is probably the biggest marketplace in Spain. Not if you look at verticals. Vertical is like the different sections, like motor, like real estate. There are some other strong competitors, but as a whole, Wallapop is the top, and that means that we have lots of users and a lot of data. So we have like millions of 10 million users per month, millions of conversations, millions of searches per day. We have a catalog of around 30-40 million items active. So that's a lot of data. It's both numerical data, it's text, is the activity of the user, is the images of the items. And during this last year, we've been building a lot of data science or machine learning products to deal with this data and get value from that. I was, at the beginning, I was mostly focused on trust and safety, let's say. So using this,
sorry?
Trust and safety. So building machine learning tools to detect scam activity in Wallapop, using tags, using numbers of the activity of the users to avoid scam happening in the platform and to block it. But also we work with many other teams to build like models to classify items and to build a proper hierarchy of items and categories. So when a new item is uploaded, we can know if the category is right, or if we might want to change it to improve the findability of the item. So that's the thing. I don't consider myself an expert, but in the last year we've been working a lot on making machine learning products to bring value to the platform and integrating them in the production environment with all the requirements that it needs. So I discovered this word, machine learning operations, or data machine learning engineering, which is at the end taking a model that is trained and putting it in the production environment for other services and apps to use it. And that's been really interesting to learn.
Nice. So yeah, you work with any particular kind of data other than what you said, or?
It's mostly about text. We also have images, but we don't use it that much. But text is quite common. So let's say if we want to about the classification problem, which is quite easy because we have a lot of not easy, but we have a lot of data, and we have several categories that we want to classify the items into. We can train neural networks based on the text of the title and description of the item to properly classify the items into categories, and that works quite well. If we also put the images, so we use both the images and the title and description, then we get really good accuracies. But on the downside, that's much harder to train and much harder to use in real time, because you have to process all the images and text of the items that are being uploaded, which is in the order of 1 million per day. So you need a lot of computation power to use that. So it's in business is always the balance between having a great accuracy and being able to use it in the production environment that is needed and meeting the requirements of the platform.
Right. So you may have a lot of data, but perhaps the computing power is also a bottleneck.
It's part of the challenge. So definitely. At the end, the challenge is being able to scale these models. So actually, that's something that I missed in many of the data science courses, is that you learn how to train a model, but the story ends there. So you don't know how to use that model in a production environment. You kind of know that you can build a web service to expose the model and consume it with requests, but you don't really learn how to make it scalable. And maybe it's not the role of a data scientist, but it's part of the issues and part of the role that I'm taking at Wallapop. Is this step in between data science and engineering, which is what is called machine learning operations, and how to take this model and package it so it can be available in production and scale whenever the demand scales. And the other important thing, for instance, is how you retrain the model if needed. So for the case of scam, if scammers change the pattern of activity, you might want to retrain the model in order to capture the new trends and to detect them as efficiently. So how you build the pipeline to retrain the model and redeploy it, ensuring that the accuracy is better than before. And all this architecture is not really maybe data science in the exact term, but it's really related. And this bridge between bringing data science to a production environment.
Right. I also see this trend, like data science and data engineering are kind of merging, or at least speaking about job requirements, they overlap a lot.
Yeah.
So what would you say is what is the tech stack that you use at Wallapop in late 2020?
So I would say Python. Python is the basis. There's this discussion Python versus R in data science. I like Python. I love Python. I don't know that much about R, so I cannot compare fairly. But yeah, Python is a must, and also SQL, as I was saying. Everything at the end is stored in databases that you need to be able to access. Maybe in some jobs you might have like the people that will give you the data set all prepared, but I think that in many other scenarios you'll have to go and get the data by yourself. So Python, SQL are the tools, the basic tools, and then all the standard libraries for data science. So scikit-learn, pandas, keras with TensorFlow, and so.
What about?
Yeah, go ahead. No, I haven't worked that much with other deep learning libraries like PyTorch, but yeah, basically that's the stack.
Yeah, I would say PyTorch is perhaps more frequent in research than industry. And what about the data engineering side? Which are the technologies?
So yeah, so at Wallapop, the technological stack is built on top of Amazon Web Services, and we use that a lot. So our databases are in AWS, and also the tool that we use to productionize, to bring to production the machine learning models, which is called SageMaker. It's also part of Amazon, so we use that a lot. So yeah, basically the tech stack from that side is Amazon. There's Google, there's Microsoft, but in our case, is Amazon.
You don't use a Spark?
No, Not yet.
Right. Yeah.
At some point, we use it. I'm not the one using it really, but yeah, we have some projects in the short future that we might need to use it. We have a lot of data, but not that much, or we don't use that much for our specific needs.
Yeah. Yeah, it's getting big, Spark. Although perhaps I don't know for modeling if it's that good, but yeah.
Actually, that's the thing. I don't have much expertise with that, so maybe that's why I haven't used it. I should start, but also because we didn't have the need. So even if our models are might be quite big, and we might be using a lot of data, for the case when we use images, we take smaller sets, and it works just fine for our cases. The thing is, with that much of data, is that we have data for every single need that we have. So we can build models for many things, but we don't use all the data available. We can just take some samples of that.
Right. So perhaps you don't need, you just need the relevant data to train.
Exactly.
That's a good point.
So we are working on a project right now about improving the relevancy of the search engine, meaning that when you get the results, when the user performs a query, we want to be able to sort the items based on the relevancy that we believe it's going to have for the user. And learning this is a quite tricky problem. It's called learn to rank, and it's quite complex, and you didn't need a lot of data at that point. So we will be using all the data coming from all the searches that the user performed, and that scales a lot. So if in a day we have like 1 million, 10 million searches of all the users, and for each search you have 10, 100 results, and you start putting rows for all of that, you get a lot of data, tens of gigabytes of data. And at that point, we might need to look for other tools. But I believe that for building something at the beginning, you can work small and take some subsample of that. Only when you get really good at that, and your model is really capable of getting the complexity of the problem, you start needing to use all the data.
Mm-hmm. And why do you say it's a challenge? Because of the volume, or?
Yeah, because of the volume. So you can use smaller samples of data, but still it's a huge volume, and also because of how the problem has to be framed. So it's not like a simple classification problem, because from 100 results you may only have one conversion, one click, or one chat, or one favorite. So the problem becomes really sparse, and you have to be smart on how you frame it as a machine learning problem. Either you try to predict if the item is going to be click or not, and sort by prediction, or you want to compare two items and say, okay, this one is more likely to be click or converted than this other one. And that's not as simple as just a classification problem. And finally, the last challenge is how to make it robust, how to make it that it can be used in real time for any single search. You need to run the prediction against the top 1,000 results and sort them by relevancy and give them to the user. So you need to do that in milliseconds, taking into account that you may have a lot of searches at the same time. So the model needs to be fast. And for that, we're working with the engineering team in charge of the search engine, which really know a lot about the infrastructure. So we were collaborating to see how we can build this model.
And now maybe I'm pushing it too much, but as a mathematician, have you like given some solution to improve speed, or like I don't know,
to improve speed,
or do clever things? Not yet.
No, I don't think so. No, I'm not sure. I'm not sure to or either understand the question or if realizing if really mathematics at some point had helped me. At the end, so that's something that you learn that that performance is really important. Not only if you want to bring the model to production, which of course needs to be performance and following the requirements of the infrastructure, but also if you want to, when you train the model, you can do the code poorly, or you can do it faster and really performant. And maybe not mathematics, but knowing about Python, computer engineering, and so makes the difference. Knowing which functions are faster for which actions, and really making the most of it. It might make the difference of training a model and taking 1 hour to just 2 minutes. Apart from that, mathematics in that particular case, I'm not sure it helped.
Yeah, like I don't know, parallelizing matrix operations, but yeah, that's kind of what you explained about knowing the cost of each thing. So yeah, unless you want to mention any other interesting project in Wallapop, we can go.
No, basically that. It's been a year. We've done a lot of things, but yeah, it's basically that.
Okay, so what achievements you never imagined you would get when you were a student?
Actually, I would say 2 things. One is working as I'm doing as a data scientist at Wallapop and knowing all of that. So I didn't know that much about data science or machine learning a couple of years ago, and now I'm able of doing this. Maybe not the top state-of-the-art models, but helping with machine learning to solve real life problems in a tech company or in a mobile application like Wallapop. And the other thing was that my experience in Abu Dhabi, the chance that I had to work there, only when I had a couple of years of working experience, it was surprising. Like being there and talking to some senior manager or top level in the companies was surprising. Not sure how I got there, but it was nice.
So yeah, like how was the place? Was it like a skyscraper thing?
Yeah, totally. Working in the 60 or 50 floor in these super fancy offices. Maybe at the end they had a lot of money. The job might not be the most how to say the most innovative one, but it was a good opportunity.
Yeah, and what about Wallapop? How's the office or the culture or yeah?
Actually, the culture is really nice. We're growing a lot, so if there's anyone interested, we have many positions open. I think it's really it's a really nice place to work. And yeah, well, actually, the brand reputation that Wallapop has among the community, it translates into the place to work. So it's really nice. The the people and all the relation you have with the company is really nice.
It was a startup, right, at the beginning?
Yeah. I'm not sure about the definition of startup. I heard sometimes that it's up to 5 years or 6 years, then you're not called a startup anymore. Wallapop is 6, 7. So I'm not sure if it's still a startup, but yeah, at the end, the idea is that at some point it was a startup.
Yeah. So yeah, it keeps the culture, the startup culture.
Totally.
Yeah.
But we are around 200 people now, so imagine.
In your department or?
No, the whole Wallapop.
Really, just 200 people?
Yeah. For
the biggest marketplace, yeah, this internet is crazy.
You think it's nothing, but actually, with many people I talk, I think they say it's a lot, because they just see an app, you see a mobile app, and say, okay, that's 10 people max. But no, there's a lot of work to be done.
Yeah, but the volume of money it moves is huge, right?
Yeah. Actually, a lot of money. It took some time for Wallapop to find the way to monetize it, but yeah, we're getting there.
What do you mean? Like, what's the business model?
Exactly. So at the beginning, the revenue that Wallapop was getting was small, and they started looking for ways of monetizing it that couldn't hurt the society or the people using the platform. And at the end, you realize that apart from ads, external ads from advertisers, normal people using Wallapop don't tend to spend a lot of money. So they are not trying to get the most of everyone, but they are providing useful solutions. So on one hand, there are professionals that pay a membership to have like more visibility and a proper place to show the items. But then they are introducing partnerships with shipping services like Correos or like others, Seur, and we get a part of the fee of the shipping fee of the items. And at the end, it's not a lot. So for each transaction, you get just a few cents or a few euros, but at the end, it adds up. So people don't spend a lot of money, but Wallapop manages to survive, to earn money.
Yeah, but they use Wallapop, right?
Yeah.
So, yeah. Okay. Like, is there like a percentage of the transactions that goes to Wallapop, I guess, or not? Totally clean.
I'm not sure if it's
Yeah.
a percentage, but it might depend. It's a relation between the price, the price of the item, the percentage, and yeah, you have some minimum and maximums at the end. So it's not only a percentage, but we can, yeah, basically.
Okay. That was interesting. What's your opinion on data science? Which trends do you see, especially in your sector?
So how I see that science is what we were saying, that there are many positions, many names for data science or data related jobs. And it's hard to know what is data science and what it's not, and we may have different definitions. But definitely there's a boom. So there are many things we can do with data, and companies are starting to realize it. There are some companies that are already aware of that and that are already using data and data science for business purposes, but it can still grow a lot. So I guess that in the future we'll have still more positions for data science. On the other hand, we have like big companies like Microsoft, Amazon, and Google that are trying to make data science easier for companies. So they have these products that you just do a couple of clicks and you can train a model, like if you were doing some computations in Excel. And that's bad for us because we might lose our jobs, but still we will need expertise for understanding what those tools are doing behind the scenes. And definitely on the research side of data science, there's a lot of things that can be done. So there are crazy ideas and application of data science that you could never imagine, like GANs architectures and crazy things with neural networks that you are surprised. And all those applications in like, I don't know, self-driving cars and robots. I think we will have data science for a long time. Not sure if in all companies and in which will be the roles, but I think we'll have data science for a long time.
And data scientists?
Hopefully, yes. No. So I think we still have to reach a peak where many companies. So that's the thing. So some companies are already following the trend, but there are many companies that still have to. They can only imagine doing business intelligence, and on top of that, you can still do data science. But at some point, data science will be probably normalized and used. The most simple part of data science, like building simple models for business purposes, will be normalized, and and maybe we are not needed there anymore.
You know what Pau told me the other day?
What?
He said, like, this is like the DNA sequencing. At the beginning, it costed like millions of dollars, and today we get it with an app or like, well, and a sample in for just less than 1,000. So
Totally, that's totally, yeah, I think that's a similar case. So 10, 20 years ago, building a machine learning model was like something strange for a company. And now we're getting to this point that you can build it with few clicks. And we'll probably, some people say that we may get to the point that you have a black box, you pass it a CSV with some data, and it gets builds a model without you really knowing which kind of model, how it has been trained, and so, and without having to care about how to train accuracies and all the metrics, and so we might get to the point at some time. And probably Google and Microsoft and Amazon are leading into that direction, because that's part of their business.
yeah, I wonder how much small companies can do in that aspect, like making data science as a service. Should it be exclusive to Google, or can someone in a garage make it happen?
That's the other thing. There is room for companies providing data science tools, let's say, so for Google and Microsoft and so to build a data science platform so companies can use data science. But there's also a lot, and I think we can explore that. There's a lot of room to work there for building the data science product. So a company focused on only building a data science product. I don't know, cameras for detecting something, or I don't know, many applications of data science, and companies can be built around those applications. As you were saying, someone in the garage can find a nice application of data science and build a product around that.
Okay, interesting answer. Thank you. What's your next goal in your career?
So so as you saw when I introduced myself, I've been moving between academia, research, and business. So I did some really theoretical bachelor, and then moved to business, and then back to a master's. So I'm still considering the idea if a PhD is suitable for me, if I like it enough, or if I have the perseverance needed to follow it. So that would be one of my possible futures in the short term. But I'm not really sure right now. So I'm happy where I am and what I'm doing. I still have a lot of room to improve. But at some point, I might like to like really get the expertise on a specific domain that I get to enjoy.
Do you think you could make a industrial PhD in Wallapop?
That could be, not sure in Wallapop. That could be discussed, I guess. But yeah, I guess the industrial PhD formula would work for me, because I like being in this middle, in this center, like in between academia, research, and business. So yeah, definitely that would be something to consider.
You get the money and you get the status. No, it's not about that, I know, but no. It's a joke.
But yeah, so at the end, the PhD is about really getting deep into a single, so getting the expertise in a domain. I don't see myself getting this expertise in something really theoretical and beyond the society or the business side of the community. So that's why I like the idea of getting the expertise, but something related to real life problems.
But you mentioned quantum computation. Can you explain more about that?
Yeah. So actually, yeah, I did the final bachelor degree project in that field. And I like it a lot. I like the idea of quantum computation and quantum computers performing better than classical computers. It was a new field, and it's quite a new field. So I thought, yeah.
Can you like start by defining what is quantum computation?
Yep. So basically, if I remember it right, the idea is that classical computer works with bits. It can either be a 0 or a 1, and a quantum computer leverages the quantum physics of particles to have states that can be the combination, the superposition, the quantum superposition of different states. And that allows to perform much more complex and much more faster computations than a classical computer. In mathematics, there are these problems that you say cannot be solved in a polynomial time with a classical computer. But when you enter the quantum domain, there are some other problems that become solvable. For instance, the current security systems that we have in place based on different cryptography algorithms could be break with quantum computers easily. The only challenge is that quantum computers are not really a thing yet. So there are some computers built. One of the top is IBM. But those are not really useful yet because those are not really complex enough or have not grown enough to be able to outperform classical computers. By the way, when we reach to that point that a quantum computer can overcome a classical computer, it's called quantum supremacy. We're not there yet. So at some point, quantum computers will be a thing. Right now, it's just not theoretical, but research is going on. And yeah, as part of research, there's some people working on the idea of if quantum computers can solve mathematical problems faster than classical computers, and machine learning is basically an optimization problem, what can we do with quantum computers? And they are starting to develop quantum machine learning algorithm to show in a quantum computer to train models much faster.
Just theoretically, right?
Yeah, right now it's theoretical because they don't have a real quantum computer to test that. So the unit of measure of a quantum computer is it's called qubit, like a bit, but quantum qubit. And yeah, basically the size of the current quantum computers is few hundreds qubits. It's not that much if you compare with a classical computer, and we need many more. I don't remember the ratio, but we need many more qubits in order to outperform classical computers. So you can play around with those quantum computers. For instance, Amazon in all those tools that has in Amazon Web Services, there's a specific tool that you can use to run algorithms on top of quantum computers, on simulators, and then on real life quantum computers. But it's basically for testing purposes and theoretical. It's not that you can really get anything useful from that apart from what you learn and what you test.
Yeah, maybe it will happen like in normal computers that once the hardware is available, the theory booms.
Exactly.
Or perhaps people is just ahead nowadays of.
It's in the middle, I would say. So, for instance, my thesis, my bachelor thesis was about developing a quantum algorithm to count prime numbers efficiently. And as you might know, some people might know, prime numbers in mathematics are a very strange topic because they don't follow any clear pattern. You don't really have a proper test for an efficient way to test if a number is prime or not. And basically this algorithm could allow to understand better or count primes given a top number. And yeah, the idea at the end is we start building algorithms that could be useful in those scenarios, the scenario of having a quantum computer, and some other people is trying to solve this problem, how to build a quantum computer that is efficient, that is robust, because the problem is how to manage the interaction of single particles that encode the quantum computer.
Because now that say I'm not really an expert, like totally not. But is it like a probabilistic computation?
Yeah,
right?
you have all the quantum computations has quantum physics has all the probabilistic component, which is the probability of a system in being in one state or the other. So at the end, the quantum computer is probabilistic. And I think the problem they have right now is that you have to manage the errors that you get between those probabilities and the particles, the single particles that you have in the system. I'm not really an expert, so if there's some expert watching this video, might get crazy, but that's more or less the idea I have. But basically, at the end, I'm not sure if I will be working on that, but at some point we might have algorithms that can be run in a quantum computer and make the optimization part much faster.
Instant learning, instant training.
That would be interesting.
Yeah, I don't know if there's something in particular you could do with machine learning and quantum, other than just faster.
Yeah, there are this idea of quantum support vector machines. So at the end, bringing the quantum, the classical algorithm to quantum computers.
Okay. So finally, what advice would you give to someone starting their career?
It's hard to say because I would like to had this advice when I was starting. It's hard to find your way and to know to understand what you like, and with all what we're saying, all the roles and names, what you're really looking for. So that's the first thing I would advise. Try to understand what is data science, if it is for you, if you like this field, and in which domain you would like to be. We were talking about this Venn diagram. So if you move around this diagram and see what you like, what you would have to improve, and what can help you. The best way to learn about that is also going to conferences and meetups and so. That really helps, and also getting some expertise. You probably know Kaggle competitions, and that's a really good way to get hands-on real real machine learning data science problems that you can then use to create a portfolio of projects, and that would help you get a position in company or a job in the company you like.
Yeah, so first make up your mind and then a portfolio.
Exactly. that might be the advice, definitely.
Okay, that's good advice.
And well, actually, the other thing is to keep learning, even if you get the data science job, to keep updated with what's going on. That might be, sometimes it might be frustrating, sometimes it might be nice, but we're in a domain that is always changing, and what you learn is outdated really soon. So you really need to be updated with the last trend, what is being developed, what is the new versions, the new software, and also the state of the art in research in machine learning and artificial intelligence.
Yeah, it's nice. It's nice to stay up to date in the last things, but also if you only pay attention to what others are doing, perhaps it's not always useful. Everything, or I don't know.
You can get ideas. You can get ideas and to see if you are in the good direction or not. If for instance, if you see someone else in another company doing some similar things like to you, maybe that's a good sign. And also you can discover other things that you didn't know that can help you.
Yeah, I agree. Communication is very important in data science. That's what this is about, right?
Welcome.
So yeah, thanks a lot. It was a great interview. Now I will ask you to finally give me some recommendation of a book or a source of knowledge.
Okay. So One book that I think it might be interesting is the one that a couple of teachers in the masters in the University of Barcelona did, Santi and Laura, I think. Santi Segui, Laura igual. And it's a really nice book. But apart from that, there are plenty of courses that can help anyone to get into data science easily and probably free. There's this machine learning course by Stanford. I think it's in Coursera. Not sure if it is free or it might depend on the time. But I've been told, I haven't done it myself, but I've been told it's a really good way to start in machine learning. And then another course that I actually did it a few months ago is about machine learning engineering or machine learning operations, which is in Udacity, given by IBM and Amazon, I think, or no, Kaggle and collaboration between Kaggle and Amazon. And it's about bringing machine learning to production. So the first course would be to learn the basics of machine learning, and the second one is really useful if you want to use machine learning in business companies and to bring it to real life applications.
Right. Now that you mention it, when the pandemic started, I saw that they released a lot of books. And between them, it was this one, the one that Santi and Laura.
Exactly.
And that's how I noticed that.
Exactly. I didn't read it, but from what I could see in the pages going through it, it's a good introduction to machine learning.
Yeah, it looks very good. Thank you. And additionally, I will ask you to recommend me 1 or 2 people to interview next.
Okay.
Yes.
I might have to think a bit about that, but yeah.
Yeah. Yeah, no worries. And finally, I've said finally 3 times. Where can we find your work or your profile or yourself in the internet? If you have something.
I was saying about building a portfolio, and I don't have my portfolio really nice, but I have some things there in my GitHub page, which is a good way. If I didn't apply it to myself because I got this opportunity to work at Wallapop easier, and I didn't need the portfolio. But definitely that's a good thing, and that's something I actually have in my backlog to improve. Have some work done in machine learning data science projects that I've done in my free time, but I haven't maintained it really good in GitHub. But anyways, I have some projects there.
That works.
And also my LinkedIn.
Yeah. Everything's in LinkedIn.
Totally.
Okay. Yeah. Thanks for coming in. I hope we all learned something today.
Thank you
for a great interview.
Thank you.
Yeah. So, bye.
Bye. Thank you.